box. The chat box is in the right side, or wherever you have the go to webinar window, there is like a little box underneath that. You can type your questions and communicate with us during the webinar. By end of webinar, I can unmute you and we can talk about your projects if you have a specific questions in mind. Almost every action in your business generates data. Your sales transactions, customer interactions, even clicks on your website. This data can be a valuable strategic asset when used in your decision making. This is accomplished with data mining. Data mining allows you to find and extract useful information and discover patterns from your large data sets. This is a powerful tool for you, Analytic Solver data mining, that allows you to gain insights from your data via data exploration, visualization, forecasting, and data mining in Excel without any need for programming. And this is a time saver to help you get valuable results quickly. Today, as time allows, we try to go over all of these features. What are the steps to have a data mining project? We start with the visualization. We then switch to using classification feature, try the ensemble methods, then quick example of text mining, feature selection, time series forecasting, and also I try to show you some of the newest features of Analytic Solver for having a workflow. So this is just a summary, just to be making sure we are all having the same terminology. In Excel, we are working with a data set in Excel. Each row is called a case or observation, and columns are called variables or features. We pay attention to types of our data. If you have gender variable or sales variable, sales variable could have high, medium, or low values. This is an example of a categorical variable. Every unique value of a variable is a separate category. We have another type of data which is called numerical, such as money, age, any other continuous variable. We have a population and then we get a sample. And we want to make sure our sample is a statistically representative sample of our total population. And then before running a data mining algorithms, we kind of partition that sample into a training and validation sets to make sure we are not fitting into the overfitting trap. And the training set is used to build your model, and validation set is used to validate the performance of your model. Now, this is a general picture, general steps for starting a data mining project. Of course, you are going to start with a clear question, objective, or you might already have data, then you use the data and think about it and start like what we can predict from this data. Collect your relevant data if you haven't done so. After that, you need to get your data, clean it, and shape it. Data is never clean. The data sets that I will be showing you here today, they are all cleaned and shaped nicely. The most time-consuming stage in data mining is really preparation of your data. So, imagine you want to predict a fair market value for a house, or how many units of your product a customer will purchase in the future, or you want to classify if an online transaction is fraudulent or not, an email is a spam or not, or an applicant is a high, medium, or low risk. These are all kind of questions that can help you collect your relevant data. Now, after these steps, you have to find out what kind of if you have like a lot of variables and columns in your dataset, for example, 100 variables, a lot of those variables are going to overlap each other. Some of them have very good predictive power for your output column, a column that is your goal to predict. Some of them may not, and there are a lot of algorithms such as feature selection, sometimes visualization, that can help you focus on columns that have the most meaning, they have the most predictive power. And I'm going to show you an example of how to use feature selection. Now, after this stage, based on your project needs, you can identify the best data mining approach. You can test various machine learning models and evaluate their performance. Again, to avoid overfitting, partition your data into training and validation sets. Now, what is overfitting? Why not just train the whole data on the training and you might get a better fitted model, lower training error. The problem is that you're very likely to fall into overfitting. Basically means machine learning method will fit the model so closely to all of your specific data, the particular cases that you presented, that it doesn't generalize very well. So when it sees future data, it makes more error that you would really like to see. So we always want to hold one set for training and then one set for validation. Just before we move forward, in practice, when you are running different algorithms and you adjust parameters, you get an error for training, you get an error for validation. You adjust the parameters, your training error is getting lower and lower, and your validation is getting more. That is kind of a sign that you're overfitting. You're fitting the data very well. The training is going low and low, but the validation error is going higher up. So now, after all of this, you want to select what is the best algorithm to use. We have the supervised and unsupervised learning algorithms in data mining that you can use for building models. An unsupervised learning algorithm doesn't look for uh, predicting an outcome. They don't seek to do that. They just want to find clusters, or they just want to detect patterns and relationships in your data sets. And there are a lot of algorithms available: clustering, feature selection, principal components, and association rules that you can use for market basket analysis. Social network analysis is another application for association rules. Then we have supervised learning algorithms. The goal is to predict an outcome based on a set of features in these algorithms. Our outcome is generally referred to as a dependent variable, response, or target. So look at this data set below, just this picture. So we have all these columns that are called features, variables. Each of these is a variable feature, and each row is a case or observation. Now, I want to use all of these columns to predict the median value of owner-occupied homes. This is 24,000. So all of these columns are going to be used to predict these values. These are continuous values. So we are going to, the supervised learning is further divided into classification and prediction methods. Predict enables you to identify a value for a continuous outcome. For example, predicting a fair market value for a house. This is what we're doing here. We are using all these columns to predict the market value for a house, and this is continuous, so we are using a prediction algorithm. Now, if I want to use the cat.medv variable, we want to predict this column, you can see that if it's above 30,000, it's 0, it's above is 1, and below 30,000 is 0. So the outcome is a discrete categorical variable. So in this case, we can't use prediction algorithm. We are going to use classification algorithm. So classify allows you to predict a discrete categorical outcome, such as if an online transaction is fraudulent or not, if an email is a spam or not, or if an insurance applicant is a high, medium, or low risk. Okay, now that we talked about this, let's switch to Excel and talk about Excel Miner features. Well, Analytic Solver data mining. It used to be called Excel Miner for many years, and sometimes you might hear me say that, but that name is no longer exists. We actually have Excel Miner SDK, which is the programming API that we have for data mining. But in Excel, we just call it the whole umbrella term, Analytic Solver, and then the data mining tab. Okay, so here is Excel. So when you install Analytic Solver, you will get the Analytic Solver tab, and then Data Mining Group and Solver Home tab. Solver Home tab connects to the cloud-based version of Analytics Solver. So if you want to use the cloud-based version, upload your data set here and then go to Analytics Solver homepage. Log in with the same username password that you have for your desktop license. And remember, this license is included in your license for desktop Excel, Analytics Solver desktop. So let's go back to Data Mining Group. Let's quickly walk through the ribbon. So we have the model tab that displays or hides the task pane in the right side. After that, we have get data. Get data allows us to bring data into Excel, and we can do this many different ways. You can bring data from another worksheet or get a sample. You can get a representative or statistical sample of data from different databases, Microsoft Access, SQL Server, Oracle, Power Pivot. You can bring file folders or text data into Excel, and then you can bring big data into Excel using our Apache Spark Big Data Cluster. So let me show you quickly an example. Here's the big data sample. We have different databases that are spread across many hard disks. We're using Amazon Web Services. And now I can select one of those databases. I'm going to use Boston Housing, or we can use any of the other airline data sets. It's 120 million rows of data. So let's go with Boston Housing. You can either select all the variables, or you can select infer schema to get the variable names, and then you can check which ones you want to select. I'm going to use all of them anyways. And then we go to Options tab. Here you have the option to uh, adjust how many variables you want, what sample size would be, and then different sampling options. You can get approximate sampling, or you can get exact sampling. Let's just do 100 and click on Run. So now we're collecting those data sets from those different hard disks, and we want to make sure it's a statistically representative sample of data. Now it is in Excel and it's ready for our use in different algorithms. So next we have in the data analysis group, we have the Explorer, we have the chart wizard, that you can create, allows you to create 8 different types of charts, from simple bar and line charts to scatter plots and parallel coordinates. You could furthermore export to Power BI and Tableau if you want to get more advanced visualization outcome. Feature selection, then we have the transform feature, and this is for your data preparation, missing data handling, transforming your continuous data, transforming categorical data. Cluster analysis is one of the unsupervised learning methods. We have text icon for text mining. We have the time series method, a group that allows you to perform time series forecasting, that we're going to talk about that more today. We have the ARIMA methods, and we also have the smoothing techniques. In data mining group, you will see we have a different partitioning, 2 options for partitioning preparation for different data mining algorithms, classification algorithms, 6 different ones, and we also have ensembles of classification algorithms. Then we have different prediction algorithms, 4 of them: linear regression, k-nearest neighbors, regression tree, and then neural networks. We also have ensembles of these algorithms. And we're going to talk more about Ensemble. Ensemble is like, instead of running one algorithm, you can run 100 algorithms on different subsets of data and combine the results to get a better outcome. Association rules, another unsupervised learning method. Now, the score option on the ribbon allows you to score your new data. So you build a prediction algorithm, and then you get a new loan applicant, and you, based on your model, you want to predict if this loan applicant would be a high, medium, or low risk. You don't need to run the whole prediction or classification again. You just score your data based on the model that you have built. Different options. Help tab allows you to access examples, different user guide, reference guides for educational purposes, help text, and then if you have questions, you can go to support live chat to have a chat with our tech support. So let's go to examples and go to forecasting data mining examples. For the first example, let's open the wine dataset. Okay. So now in the right side, we have the task pane, model tab that shows the model in outline form, platform tab, lots of different options, engine tab, really not useful for data mining purposes, more into the simulation and optimization. We have the output tab, and then the main thing you would use a lot with task pane for data mining is workflow. If you want to automate your process with different steps, you can use the workflow. So first, our first example. Let us start with visualization. This is a wine data set. It includes 13 variables. Each one describes different properties of wine from 3 vineyards. Our goal is to assign a wine classification to each record. We call the wines from these 3 vineyards type, and then we have type A, B, and C. If you look, we have 3 kind of categories in the type variable. So, and these are different properties of each sample of wine. So let's start with visualization and see what it can show us. Click on Explore Chart Wizard. Let's use the scatter plot matrix. Click on Next. Here you have access to list of all the variables, so select some of them that are useful for you. Click on Finish. So you can either use all of them or just some of them. So this is our scatter plot matrix. Okay. So on the diagonal, we have histogram of our variables, and on either side, we have the scatter plots. Now, if you want to learn more about, for example, this group of cells here, this group of observations, you can select them with your cursor. They immediately turn red, not only in this chart, but in all other charts. And you can get some information about these kind of data sets, data points. So in this variable, they're all located to the left. Their color intensity is within certain range between 0 to 5. And then you can see that the OD280, there are more than 2, but really you can tell. But the proline is very low, less than 1000. And if you look to the right, you can get information about this specific observation. For example, it looked like most of them belong to vineyard B, the sample that I selected. Now, we can remove this selection or just keep it and go to color by feature. So let me show you where I am. It's color by feature. So you can look at the observations here. Here are different filters you can adjust. So let's use color by type. Now I'm using the categorical variable type to use the visualization to make it more clear. And we can see that if I remove the selection, all those data points belong to vineyard B that's colored in yellow. Now, if you want to add another chart, just go to new histogram, for example, and then we can use alcohol frequency. Click on next and finish. So now we have a histogram of alcohol, and you can change the variable right down here that you can adjust the size of bins. You can change the frequency to cumulative frequency or reverse. And you can also color by your categorical variable. When you're finished with visualization, you have the option to save the chart. So we can give it a name, chart 1, and then click on save. To access your existing charts, go to Explore Existing Charts, Chart 1. So we saw that visualization is helpful, but it wasn't enough for our purposes to draw a line to classify either whether each records belong to vineyard A, B, and C, A, B, or C. So now we can move on to a classifier model, which would automatically look at this data and fits a model to indicate which vineyard the wine comes from. And then in the future, if we get a sample that we don't know which vineyard it belongs to, based on this model, we can assign a classification to that sample. And actually, I like to show you how to do that. So let me uh, cut some of these data points and paste them here. And we assume we don't know which vineyard they. So I'm just creating for you a sample of new data set. So let's set insert. Okay. And we don't know the type, so let's delete that. So imagine this is a new sample that we get. We know that they all belong to vineyard C, but I just want to show you how to use the scoring at the end. So call that. Okay, let's go back to our data. First thing we want to do, we can use partitioning on the ribbon, but the best practice is there are partitioning options on each algorithm. So if you don't want to do that, you can use a partitioning on the fly feature. So select a cell within your data, go to classify, and for this example, let's use classification tree. Now you see all list of all your variables. On the right side, we have different options: selected variable, categorical variable, and then the output variable. Output variable is the variable that you actually want to predict or assign to each record. So type is our output variable, and then everything else is continuous, and they go to our selected variables. You can pay attention to the target here that are three classes to make sure it's recognized correctly. And then you have, this is the data tab for classification tree algorithm. Then we have parameters and we have scoring. So let's go to parameters tab. First option is pre-processing, and you can check the partition our data set. Just check it. Now you can see that there are different options. You can use automatic percentages, 60% training, 40% validation. You can use equal percentages for even have a test data set or manually adjust them. And so click on done. You can rescale your data and adjust prior probabilities. You can adjust the algorithm for fitting levels node splits. You can prune the tree, and you can use feature importance here. And then let's look at the full grown tree here. You can increase number of levels it will show. Let's go to scoring. Now you can get a detailed or summary report, and you can score new data. I will show you. Let's look at how to score our new data if it's in our workbook here. So let's clear this drawing. So the worksheet we are at is the data worksheet. The workbook is wine. We have to change this to sheet 1. And let's see. Let's adjust the data range. Click OK. Now I have all the variables, and I can match them. You see other options that we have here. We can match by name. So now that each variable is matched to our original data set. Then we can click on finish to run the algorithm. So here's the outcome or for our classification tree algorithm. Each algorithm that has this output navigator, so you can look into fully grown tree rules. This is our fully grown tree. You can see that the first variable that's used is proline. And if you hover over each decision node, you get that proline is 730 as a cutting rule. If it's less than 730, you go to left, and if it's more, you go to right side. So if you go to right, we have phenol, and after phenol, we use a total phenol. Actually, if total phenol is used twice, and if it is more than 2.05, we are sure that that sample belongs to vineyard A. Similarly, you go to left and you can see that how based on some of the rules are visualized here that you can decide if the sample belongs to vineyard A, B, or C. These are the actual three rules. Now, some of the output of the algorithm for evaluating the performance of your algorithms is classification summaries, such as confusion matrices. A confusion matrix displays counts for cases that were correctly and incorrectly classified in the training and validation dataset. So you can see it's called confusion matrix. And then you also have the error report. So you can see that our total error report is 0 and accuracy is 100%. Here you see the actual classes and the predicted classes, and then you get the error report. But usually best practice is to look at validation because the training data set was used to build this model. So of course we should get an error very low or 0. Now let's look at validation to evaluate the performance. So you can see that there are some cases that were misclassified mainly between group B and C. There were 10 cases misclassified total, and our error is 14%. Now, this is the outcome for our scoring. So those new data sets, they are all classified to group C. And we know this is obvious because we knew already that those data sets were used in building the model, but just want to show you that how you can use the scoring option to score the new data that the model hasn't seen, but this one was different, but at least you saw how to do it. And this is the stored model. So if in future you want to classify new records based on a model, you would need this PMML model. So let's try that together. So click on score. It says data to be scored. So let's select our data to be scored. It's sheet 1. And then stored model. So that two things to pay attention to here. One is data to be scored. You have to select the right worksheet and then stored model. So stored model, it was that PMM model that I showed you, and usually it will pick that up very quickly because it has that tag stored. And they're both in workbook 1. First row contain headers. Let's adjust the data range. All of this is happening because when I left this workbook, my cursor was in cell B8. If my cursor was in cell C3, for example, it would automatically recognize the cell range. Let's actually try that. Let's see if what I said is actually accurate. So erase train report. Select the cell within the data and then click on score. So we are in worksheet sheet 1. Now I don't need to adjust that. It automatically recognizes that. Sheet 1. The data range is correct and worksheet is correct. So before starting any algorithm, put your cursor where you want to be within the data set and the workbook that you want to work with. And then the tool would automatically recognize the range of data range and also the name of worksheet. Otherwise, please pay attention so you don't select the wrong data set. So now we have to match the variables. Since the names are similar, I can just use match selected or match by name, and they will match all of them. So it is matching the new data variables with our actual original data, and then click OK. And again, here's the outcome. You get the scoring report, and again, the prediction. They're all classified into Vineyard C, as expected. So this was the scoring. Now let's go back to our data set. So far, we just used one of the classification algorithms, like classification tree, and got 14% error for validation. How about we get results from ensemble methods and compare the two outcomes. So an ensemble method help us build better classification or prediction models. It's a technique for combining multiple weak learners in an attempt to create a strong learner by taking a weighted vote of their individual classifications or predictions. So let me show you actually what I mean. Let's clear this drawing. Select the cell within the data, go to classify, ensemble, and let's use random trees, for example. Well, the variables are automatically selected. We have the data tab. Let's go to parameter tab. Let's partition our data set first. Number of weak learners is the default value of 10. This will tell the tool to build 10 different classification tree and then on different subsets of data and then combine the results. I can change this to, for example, 40 or anything you want. A weak learner is one single classification tree, the one we just built. Now, number of weak learners here is 40. So let's build 40 of those together. And then you can include all of the features or whatever you desire. You can show the weak learner models. Let's go to scoring. You can score your new data again and click on finish. So here is the algorithm results. Let's go to training classification. Outcome, again, the error is 0 for our training data. Let's go to validation. And you can see that our validation error has been reduced almost half. And you can see that it is only 5 cases misclassified with using ensemble method, the random trees. So as we can see, the ensemble methods are powerful and typically result in better performance than a single tree. There's much more you can do with ensemble methods. We have bagging, boosting, and you can change the options. But this was just showing you, getting you, making sure you're familiar with using these algorithms. So in the next example, let's quickly look at a text mining model. So the text mining documents are available here in the, you have to unzip the folder. I've already done that. So let's just bring a sample of data into Excel. I need a new workbook. Let's go data mining. I'm going to bring a sample from file folder. Browse to where you have 2 subfolders. So that data set, if you open it and save it, it's from 2 different internet news groups, autos and electronics, different messages collected. So let's look at the autos, data mining, autos. You can change the file type to all file, select all of them and click open, move them to the right. Repeat the same steps for electronics. Change the file type to all file. Make sure everything looks good. I have some unnecessary things here. Check. Okay. So now we can get a sample from selected files. Let's get a sample of 300 or 200. You can write the file path or you can write the file content for your sample and click OK. Here is a sample 300. The reason I'm checking is that sometimes I saved some documents like that were not relevant automatically by mistaking that electronic subfolder. I'm just checking to make sure none of them is in our sample. Okay. So the name of this sample, data sample, is text variable. And you can see that I'm not getting the content of each file. I'm just getting the file path. So during the algorithm, we'll read the content from this file path. So this is how you import sample of data. And you can see the document 1 all the way to document 300. Now you can click on text icon on the ribbon. So text var is our only variable. Let's go to pre-processing. Here you have all the options to clean up your data. Pre-processing eliminates common words so that text mining can focus on the words that carry the most meaning. You have the vocabulary reduction. You can remove stop words, for example, a, about, above. They don't really mean anything really, and so you can adjust. You can customize these lists. We have the phrase reduction, synonym reduction. You can use term normalization. You can perform stemming. Stemming means like cut the words to the actual stem. So instead of driving, you all use drive, or and then you have other options. In the representation tab, you can get perform latent semantic indexing, and we can extract concepts from a set of documents. A concept basically just a cluster of words that tend to occur together in text of different documents. So let's keep that latent semantic indexing. Let's keep number of concepts to 10, for example. Let's go to output options. Here you can get some visualization outcomes. You can get the zips plot, for example. Let's look at the script plot for 10. And you can write the text mining model, and let's click on finish. Let's get a term scatter plot. So here's the outcome of text mining. There are some outcomes that I want to quickly go over. We're kind of running out of time. So TMTDM, it's the term document matrix. So each document is one row, and each of the terms in those documents is in a column. So basically, this is like a regular data set, data mining data set. Let me zoom out and show you how huge this matrix. So this is one of the important outcomes that basically you can use as input to any of the analytic solver data mining algorithms. We have also TM-LSA CDM. Each row is a concept, each row is a record, and each column is a concept. And this one also, along with the other one, can be used in classification or prediction algorithms. For example, you can use a classification method to create a classification model using concept document matrix to classify new documents based on the text content, whether they belong to autos group or electronics group. We have the TM vocabulary. This is the zips plot. This shows the most frequent words and their frequencies, and you see this typical rapid drop in frequency. The first term is right, articles, I think, car, and so on. You get a summary table here. This is our script plot, and this is the percentage of singular values. All of these outcomes are discussed in our user guide with a lot of information, and this is the term concept scatter plot. You can change the concepts, you can explore the terms with hovering over them. This is the recorded model if you want to use it for scoring in the future. You can use text mining for classify customer reviews as satisfied or not satisfied. You can distinguish between which products have the least negative reviews. You can extract topics of articles, cluster documents, terms, and so on. Let's go back to our the sample we got for big data sample. Okay, here it is. I want to quickly show you the feature selection algorithm. So this is a data set. Imagine you had 100 columns and you want to use feature selection to find out which columns have the most predictive power. And our test, the ideal is that finding out which houses are above 30,000, which ones are below. So I have the categorical variable as output, and I'm going to use all of these variables except MEDV as my continuous variable. So let's click on next. Here we can select different statistical tests. And then let's go to output options. We can get a feature importance plot and number of features increase to include all of them. And it's ranking by Welch's test. So I'm going to use this to give me a visualization of which variables are the most important. So here it is. We have LSTAT, RMPT ratio tags. You can see how important the LSTAT in predicting the owner-occupied home value is. If you can't just decide based on Welch's test outcome, you can go to output. Here's the whole table. You can compare different statistical tests. We looked at Welch's test. You can look at, for example, Gini index. Gini index measures the variable's ability to distinguish between classes. So the smaller the Gini index, the better. So here's a ranking based on Gini index, and you can see that these variables again show up as the most important. So you can see that in few seconds, now I have a better idea of which variables are the most important, which ones are not, if I want to perform a classification. Just imagine you had 100 variables and you don't want to sit there and manually change those variables. Uh, test all of them. Of course, you can do that. You can test all of them in your model, but this tool, feature selection, is very helpful. It's like visualization is a preliminary step that helps you narrow down and kind of reduce the number of variables that you want to use in the model. Now, before going to time series forecasting, I wanted to show you how you can use the workflow. So workflow allows you to kind of have a automated process for performing different algorithms. So imagine we have this sample of data. So first thing I want to do is to partition this data set. So let's do partition, start partitioning. So here we are working here in the data mining group, and I'm going to use partitioning, and just a standard partition, drag it and drop it here. So now I can select my variables that I want to use in my partition data set. Let's select all of them, except the record ID, of course. 60% training, 40% validation, and click OK. Now, next, we want to perform feature selection. And you can just do it right now, or we can just use one of the algorithms. For example, let's look at one of the prediction algorithms this time. Let's use regression tree. So the output variable would be value of owner occupied homes, and then everything else except that's this one goes to selected variable. Let's go to parameters. You can adjust the parameters. You don't need to partition the data. You can see if I even then we already partitioned it. We have a partitioning step. So let's go to scoring. Let's just accept the defaults and click on finish. So this is, you can go ahead, uh, have a lot of algorithm as much as you want for partition your data set, performing regression tree. Then you can use neural network, add all of those algorithms together, and then you can click on run to execute workflow. We actually have some examples ready here in the examples data set. So we have the air passenger workflow and then charge book club workflow. So let me show you the charge book club workflow. So you can see the workflow here. This is a fully one. It started with data source, standard partition. Then you can use discriminant analysis, naive Bayes, and compare and score new data. So if I just click on execute workflow, you can get all of these algorithms will be completed, and you can compare the results and get outcome. So it's a cool feature that's added. It's pretty new using the workflow. So just drag and drop what you want to do. Drag them, put them here, and then you can use this to format your workflow. So let's go back to our slides. I wanted to talk briefly about time series data. Time series data is a little different from what we have seen so far. It's a set of observation on a quantitative variable collected at equal time intervals. Stock prices, exchange rates, consumer price index, or unemployment rate are all examples of time series. What is different about time series is that so far what we have seen, these variables, each observation has a date and time on it and are usually equally spaced intervals. Since rows are ordered by time, we cannot take a random sample of time series data. So this is the first difference. In the previous data sets that we had, we could get a random sample. So for getting partitioning purposes, we cut it horizontally, draw a line somewhere in the data, and keep one part as training and one part as validation. Basically, this is what we do. Draw a line, and you can see each observation has a time tag. So we can't just get a random sample, then there is no order. Now, there's another difference. The key difference is that in previous examples, we built a model using the columns except the output column, and we predict or classify the output column. Now, in time series data, we are going to predict forward in time to the new row or several steps further in time. The columns are independent in time series, so we cannot predict across columns. But what we can do is to predict next value from previous values, which is called time series forecasting, which we're going to discuss now. Okay, so just a summary of what kind of tools are available to you. Let's open our example. We are going to use the air passenger dataset. It already has a workflow for exponential smoothing. You can see just drag and drop data source, algorithms that you want to run. You can click on execute workflow. We get the exponential smoothing outcome for forecasting. So you can see the fitted model. We didn't do partitioning, so you can see the training, actual, and forecasted models. And this is the stored model. Now let's try one more algorithm. So let's go and try to use, first let's partition this data set. In partitioning for time series, there's a little difference. So there's a time variable months, and there's passenger that's variable in the partition data. Let's click OK. Here's our data partition. Now let's go to smoothing, Holt Winters. You could just use no trend if you don't know much about this data. Months is time variable, passenger is selected variable, number of periods is 12. And let me show you what would happen. This is our training. This is our validation. We're really off. This data has a strong upward trend, and we're totally missing that with using no trend. How could have we avoided that? Usually what I would do is I would go to my data set, go to Explore Chart Wizard. I would draw a line chart in passengers. Months is our variable, time variable, and click Finish. So I didn't mention to you, this is the number of passengers and different airlines, so total number of passengers. So here's the line chart. We can see we have a seasonal pattern repeating, and we also have this strong upward trend. So we need to consider this when we are using the algorithms. So let's discard this. Now if I go back to my partition and then go to smoothing, Holt Winters, I'm going to use the multiplicative model. Time variable months, selected variable passengers, number of periods 12. Now let's click on OK. Here's the outcome, much better. So this is the training, this is the validation. Below the chart, you could also get some of the other algorithms outcome, the training and validation errors, the fitted and forecasted models. Okay, so this is what I wanted to show today, and we are already past our promised time. So let's just talk about a summary of what to consider, some key steps. Please don't skip the first steps. This is to think about your data, collect the relevant data, clean it, shape it. Have a clear question or objective in mind, and then you can always find the columns or variables with predictive power, use feature selection, use visualization. Then you can partition data into training and validation set, train the model, then validate it. Try multiple machine learning models. To validate, to compare the results, you can check performance on both training and validation. Remember, validation is more important. We looked at confusion matrices today, but there are charts such as lift curves, RROC curves with that come if you get a detailed report. We didn't look into those, but they are available with our products. And then you can check the most to find out which variables are the most important from even the outcomes. And then you can try ensembles of weak learners. You can use multiple machine learning models trained on different data subsets. You can use bagging, boosting, and random forest, and this usually yields better result than a single algorithm or weak learner. After that, apply the best model to your new data. You can score on Excel worksheet, SQL database, or another database via PMML model. I showed you that a PMML model is that recorded model. And here is a final recap. Every action in your business generates data, and this data can be a valuable strategic asset for your decision making. And data mining enables you to use that data to find and extract useful information, discover patterns, and gain insights from your data set. And this ability to use data intelligently is now a vital skill for any analyst. And Analytic Solver gives you all the tools you need to visualize, transform your data in Excel, and later apply supervised and unsupervised learning methods without any need for programming. This is the whole picture for data mining software. If you have been with us for this whole series of webinars, we started with looking at Analytic Solver uh, optimization tools. Yesterday, we looked at simulation, we touched on stochastic optimization, and today we focus on data mining. And these are all the tools you need, all the advanced analytic tools in one software. And this software has also some other capabilities. We talked about how to use the big data today. We talked about how to use a create app feature if you have a web or mobile application. So all of these are available in one single tool called Analytics Solver. If you want to use all the features with no limit, you can always use the Analytics Solver Comprehensive. If you have any questions, feel free to contact us at this specific number or reach out to me at consulting@solver.com. Thank you very much for your attention. I hope this was helpful. Let's look at your questions. So Steve is asking if there are other additional resources on our website. Yes, we have the YouTube channel. So let's go to YouTube channel and show you what is available there. So let me open it first. So this is our Frontline Solver YouTube channel. Its user is Frontline Solvers. I'm going to share this link with all of you in the chat box. Okay, so now here you can look at all these demo videos, product overview videos. These are getting started, some basic videos. There are some playlists. You can look at these for Excel Online, different options that are available. All webinar recordings, data mining videos are all listed here. So if you're interested, this is what you're looking for. There's some older Excel miner videos, so you just go to data mining videos. And there's an overview of data mining here. So there's a lot of demo videos are available. We also have Solver Academy that offers you some courses. So let me open the link to Solver Academy. Here's the Solver Academy page with different courses that are available: data mining, step 1, step 2, optimization, and simulation. So if you're interested, you are welcome to look into the educational course options. We also have different user guides. Now, if you go to Analytic Solver page, under support, there are recommended books. Data mining for business intelligence. These are the books that use our products. And you can use any of these books if you want to learn more about our products. This one is more focused on data mining. It's really a good book. Now, if you go to tools, wanted to show you that we have the developer tools, which is the Excel Miner SDK platform. So this tool will allow you to use forecasting, data mining, text mining in your application. If you want to work with C++, C Sharp, Java, Python, or R languages, this tool will work with you. So these are all other features that are available to you. This is a totally different tool for instead of using Excel, if you want to program and have more sophisticated algorithm, this is what you can use. So the Solver Academy courses, they are both in the whole area of data mining. It has a 1 week or 2 weeks on a time series for forecasting. So it just covers everything. And there are, I think, 2 weeks or 1 week worth of data time series forecasting. It's not just on time series forecasting. Okay, thank you very much. I appreciate your attention and your time. You will receive a survey. Please provide us with your feedback and suggestions. We are dynamically changing these webinars, and your feedback is very helpful. What features do you want to see if you have a more advanced version of these webinars? These are designed to bring your knowledge and get you familiar with our products. And after this step, what would you like to see? We have a specific webinar for our current customers called office hours. So during those office hours, we talk about more advanced features. So if you're an existing customer, reach out and we can invite you to those webinars. Thank you very much for your time. Have a wonderful rest of the day. Bye for now.